All right, this is conservation of momentum. And in this problem, we're going to have two hockey pucks and they collide and then they go off in different directions. So again, this is conservation of momentum. So it says hockey puck B rests on a smooth ice surface and is struck by a second puck A, which was originally traveling at 40 meters per second and which is deflected 30 degrees from its original direction. Puck B acquires a velocity at 45 degrees with the original velocity of A. The pucks have the same mass. Compute A, the speed of each puck after collision. So I want to find VA prime and VB prime. What fraction of the original kinetic energy of puck A is dissipated during the collision? All right, so there's more than one way to do this. So the first thing you have to remember is that momentum is a vector quantity. It has both magnitude and direction. And this is frame of references. We're looking at it from above. So the total momentum before is equal to the total momentum after. So before, the only thing we see here is the puck A. So the total momentum before is this mass times this velocity. Now remember that they're equal. So in this case, because they're equal, instead of calling it MA and MB, we're just going to call it plain old M. Okay. So we also know that VA is equal to 40 meters per second and VB is 0 because the hockey puck B is at rest. So the easiest way to do this is to do what's called the momentum triangle. Okay. So that means that this vector here is equal to this vector plus this vector. But these two vectors, because momentum is a vector quantity, it has to be added head to tail. So this is PA prime and this is PB prime. So the total momentum before is the momentum of A before, which is just this. So what I'm going to do is I am going to redraw that right here and say that the total momentum before is the momentum of A plus B, PA plus PB, times, and I know that's going to be 40, which is the velocity, times the mass, okay, M. So this is 40 meters per second, and then the mass of A is 40 because PA is equal to MAVA. So the total before is just the momentum of A before collision. Then what I do is, let's say this is where I start, and this is where I end. So what I'm going to do is PA prime is 30 degrees. So I'm going to go like this. This is PA prime. From the head of that vector, and this is 30 degrees, I do the tail of the other. So this is 45 degrees. So this is 30, this is 45. So I know every triangle has 180 degrees. So 180 degrees minus 30 minus 45 is equal to 105 degrees. So this is not a right triangle, but that's what you do in high school problems. So whenever I have a triangle that's not a right triangle, I have to use either law of cosines and law of sines. So in this case, I'm going to look at this. I have the hypotenuse, and I want to find the other two sides. So if I use law of sines, I'm going to say A over sine of A is equal to C over sine of C. So if I call this A, this B, and this C. So PA prime over the sine of 45 is equal to 40 over the sine of 105. I'm just getting rid of the m's since the m's are going to be carry out. So PA prime is equal to 40 sine of 45 over the sine of 105. So if I put that on my calculator, PA prime is equal to 29.27 kilogram meters per second. Now, if I wanted to find PB prime, I could again, I would not want to use law of cosines because that would just be too much. So I'll just use law of sines again. So PB prime is equal to 40 sine of 30 divided by sine of 105. So that's, when I do it on my calculator, I get 20.7 kilogram meters per second. Now, if they ask me for the velocity, okay, but I don't have the mass, remember that P is equal to mv, so if I wanted to find the velocity here and I knew the mass, I would say v is equal to P over m, and then I could find it, but they don't give us the mass. The other method to do this is, what you would do is, you would take each vector like this, and you would find the horizontal and vertical components of each. So let's say I was doing the x. If I summed forces in the x, I would say that the 40 is equal to this plus that. So it would be PA prime cosine of 30 plus PB prime cosine of 45, and then I would substitute in all my values. But then I'm still going to have two equations and two unknowns, because I'm going to have PA prime and I'm going to have PB prime. Then I would have to do everything in the y. So in the y direction, this is 0. So I would say 0 is equal to PA prime sine of 30 plus PB prime sine of 45. So again, my unknowns are this and this and this and this. So I'm going to end up with two equations and two unknowns. So that's a lot of math. I would not do it that way, because you're going to get the same equation, but the math is hard. This math is very simple as long as you know law of cosines and law of sines. But maybe you won't think to do it that way. Part B says the kinetic energy. So the original kinetic energy is equal to 1/2 mv squared. So it would be 1/2, I still don't know that mass, times 40 squared. So it would be 16 divided by 2, 1600 by 2 joules. But again, I don't know what m is. After, it's going to be 1/2 m, and then the answers I found, 29.3 squared plus 1/2 of m, 20.7 squared. And then when I do all that, whatever this comes out to be, I think it's like 643 m. So then what I do is I subtract it, and I say 800 minus 643 is about 157. And then they want the percentage. So then you find the percentage of this over 800. And remember, percent means something over 100. So then you find out that this is about 19.6%, which that question's weird. But. So the whole thing is, when I have a collision like this, the total momentum before is equal to the total momentum after. But because momentum is a vector quantity, I can't just add it algebraically. I have to add it vectorially, which means adding these head to tail.